In this video, we will be looking at direct variation. By the end of this lesson, you should be able to analyze a relation to determine whether a direct variation exists, determine the constant of variation, and represent a direct variation algebraically and graphically. Let's take a look at what that means. So first of all, let's define direct variation. Direct variation is the relationship of two variables, x and y, such that y equals kx. Something important here to remember is that k is not 0. Now this is not something entirely new. We've seen something like this before when we looked at y equals mx plus b. Direct variation is a special type of line where we have y equals mx plus b, but b is 0. That's why you see we only have two letters here. My m and my k are the same. We just write it a little bit differently when we talk about direct variation. Direct variation because b is equal to 0. If I draw this on a graph, notice my y-intercept is 0. This graph goes through the center. It goes through the center because b is equal to 0. That is our direct variation. Now we talked about a lot of letters here. Sometimes it doesn't have to be x and y that we use, as in y equals mx plus b. We have our y and our x here, which we've really only seen so far. But sometimes with direct variation, we have some other letters. So this example says m varies directly with n, can be written as m is equal to, m takes the place of y, k, and n takes the place of x. So we can see different letters and different relationships with direct variation, but it's all the same. Direct variation just means it's a line that goes through the center. Our constant of variation, or you may see this defined as constant of proportionality, is the number that relates the two variables. So this was our m in y equals mx plus b. We call it k when we talk about direct variation. It is the same as the slope of the line, or m. M is the same as k. So let's take a look at some examples. Example 1, are the equations below direct variation? If so, identify the constant of variation or the constant of proportionality. So we have to figure out what k is, if it is direct variation. When we solve these, if it's not in y equals, you want to solve for y. So let's take a look at our first one. This one is already solved for y. So I want to just take a look at it, and it says y equals 1/2 x. In this case, I see my 1/2 here. So this, yes, this is direct variation. And k is equal to 1/2. If we look at my next example, I don't have y equals yet, so I need to solve for y. So in this one, I have this minus 5x here, so I'm going to add 5x to both sides. I have y equals 0 plus 5x is just 5x. Remember that identity property. So now I have y equals 5x, and I see here my 5. So yes, this is direct variation, and my k is equal to 5. If I look at example 3, I have y equals x over 8. It has y equals, so I don't have to do anything there. And it doesn't exactly look like my other ones, but remember that we can also write this. If I have 8 in the denominator, this is the same as y equals 1/8 times x. these two things are the same. So when I look at that, I see y equals k, a number, times x. So yes, this is direct, and my k is equal to 1/8. Looking at my next example, it has y equals 8/x. So in this one, it's a little bit different because from my other one, because here this had x on top, this one has x on the bottom. So this one can also be written as y equals 8 times 1/x. And this will be a little bit different. Notice how here x is in the numerator, here x is in the denominator. So this one is not direct variation because x is on the bottom. And finally, let's look at our last example here. I have y equals, but here I have 3x minus 1. So here my b is equal to -1. And remember we said for direct variation that b must always be 0. So this one is not going to be direct variation because b is equal to -1. Let's take a look at some tables. In example 2, we want to determine which tables below represent direct variation. If it does, identify the constant of variation and write an equation. So we want to find k and then write an equation in y equals kx. So let's look at our first table here. I have x's and I have y's. So I want to see if this one is direct. I want to see if that equation works. So I'm going to come on the side, and you can feel free to use your column on the left as well. I am going to see if any of these give me the same constant of variation for each point. So for the first one, I want to say here's my y coordinate. We're going to substitute like we did in our earlier lesson. So I'm going to substitute 2 in for y equals, I don't know what k is, but I know x is 1. I want to solve for k, so I divide both sides by 1. K equals 2. So for this one here, k is equal to 2. My next one, I have 2 and 4. Again, I follow the pattern y equals, so here's my y coordinate. 4 is equal to k times 2. Divide both sides by 2. K is equal to 2. I'll do my next point. Same thing, take my y coordinate. 8 equals k times my x, which is 4. Divide both sides by 4. Again, k is equal to 2. And lastly, I have 18 as my y equals k times 9, my x. Divide both sides by 9. K is equal to 2. So if we notice here, k equaled 2 each time. So that means this one is direct variation. And our equation is y equals 2x. I have written my equation. Once I know what k is, I have to find k for each of these points. And it must be the same. If we got a different number here, this would not be direct. They all need to be the same. And once they're the same number, then I can write my equation. Example 3. Let's take a look at some graphs. Which graphs below represent direct variation? If it does, identify the constant of variation and write an equation. So we need to figure out again what k is and write an equation in y equals k times x. So let's take a look at our first graph here, and we want to write the equation y equals k times x. So first I want to notice here, remember that my b must be 0, because I have y equals kx plus 0. My b is 0. So for this graph, my y-intercept is 0. So that works. Now I need to figure out what my k is equal to. Now remember back that k is the same as my slope. It's the same as m. Remember back that k is the same as my slope. It's the same as m. So when I am writing this equation here, k is equal to, I can look for my slope. And I have another point here. So I go down 2 and to the right 1. So 2 over 1. And I'm decreasing. I have negative slope. So I want to put a negative sign there. So k is equal to negative 2 over 1, which is the same thing as 2. Y equals negative 2 times x. That is the equation of my line. Let's take a look at a word problem here. So this problem does not give me a table or a graph or an equation. We're going to have to write it ourselves. So in this example, it says if y varies directly with x. So let's take a pause there. If y varies directly with x, so that means I know this. Y is equal to kx. Then the next part of the sentence says, and the constant of variation is negative 6. Let's stop there. Constant of variation, that's k, is equal to negative 6. We need to write an equation that represents this. So if I know on y equals kx, k is equal to negative 6, I want to substitute y equals negative 6x. And there is my equation. This is the end of our video. Please bring your notes to class so that we can continue to look at examples and practice using direct variation.